Hello everyone, this is Oliver from the Maths Helpers bringing my first video for my series on FP1. This one's going to be on matrices. Alright, so in order to get your mind in the kind of mindset for matrices, we need to consider when a matrix might actually be viable. So to do that, I've devised a situation here. So suppose we have three cities here, three European cities. We've got London, Paris and Amsterdam, and we're just going to consider how we could model a table to display the flights between these cities. So we have edges between each node, we have a number displaying how many flights are offered between them, and let's just think about how we could use a matrix to model this. So first of all, we need to show what a matrix actually is. So a matrix is a table of information that, you know, displays numbers, mathematical objects, information in kind of like a elemental form. So each element here, you can see, has its own row, its own column, and we can identify each element separately using purely its row and column. So let's think about how we could use this matrix idea to model this situation here. So let's call the airline company Airline A. And it's going to be a 3 by 3 matrix, as we have, of course, 3 cities. So let's just abbreviate this. We have L for London, A for Paris, A for Amsterdam and P for Paris, and then we have L for London, A for Amsterdam, P for Paris. Right. So let's consider all the flights incoming and outgoing from London. So we can see here between London and Amsterdam we have 3 flights. So write 3 here. From London to Paris we have 5. And you can see the symmetry in this matrix, so we can write the exact same thing down here, as Amsterdam to London has 1 flight and Paris to London has Amsterdam to London has 3 flights and Paris to London has 5 flights, excuse me. And of course the trivial thing here is London to London, which is of course going to be 0, as I don't know about you, but I don't know any airlines that offer flights to its own airport. So let's just consider Amsterdam now. So Amsterdam to Amsterdam is 0, and Amsterdam to Paris we can see there's 4 flights, and we use the symmetry of this matrix to write it down here as well. And then Paris to Paris is a trivial 0. So let's look at what we've done here. We've displayed this information in this graph here in a matrix form. So each node of the graph, London, Amsterdam and Paris, is a respective column and row, and we display between them, between the rows and columns, the amount of flights between the different nodes. So this is a practical usage of a matrix and should hopefully open up your mind to their use a little more. So here's a scenario for you we're going to consider. So let's suppose there's a second airline, Airline B, that offers a slightly different assortment of flights. Most curly bracket I've ever drawn in my life. And let's suppose this one is 0, 0, 0 again. I actually might annotate the exact rows and columns in use here. So L, A, P for London, Amsterdam and Paris. So let's consider this for a second. Let's say there's 2 flights from London to Amsterdam, 3 from Paris to London, let's say 4, no, let's change it up a bit. Let's say there's 1 flight from Paris to Amsterdam in this strange airline company. Let's just suppose for a second that we want to find the total amount of flights offered by these 2 airline companies together. So in retrospect, what we're finding here is the sum of the matrices A and B. And this is an example of matrix addition. So we're introducing matrix addition. So how are we going to find this? Well, consider what we're actually finding here. We're finding the sum of all the flights offered to these locations by both the airline companies. So what we're going to do is we're going to add the 2 matrices element by element to their corresponding element. So if I just maybe this will help illustrate it a little more. If I just quickly rewrite both the matrices. So, just won't take very long. 2, 3, 2, 1, 3, 1, 0. And we're going to find the sum of these two matrices. So, okay, let's just quickly write down here. So, let's add element by element. So, element 1, row 1, 0 plus 0 is 0, obviously. Then 3 plus 2 is 5. 5 plus 3 is 8. 3 plus 2 is 5, and you get the picture. You get what's going on here. We're just adding element by element, each element to the other element. And there's a little thing you might be wondering here. Well, what if we're adding, let's say, a 3 by 3 matrix and a 2 by 2 matrix? Well, I can tell you now that addition for what they're called non-conformable matrices isn't allowed. So you can only add two matrices that have the same dimensions. So that's a very important note. I think it's worth illustrating here. So addition only defined for same dimensions. Okay, so this matrix here, A plus B, is the total amount of flights offered to these locations by airline company A and airline company B. So that's pretty simple, and subtraction works in exactly the same way. So if you want to subtract two matrices, it's the exact same thing as adding them, the same process I should say, but rather than adding the two elements we subtract, obviously. So I don't think that's worth an example. And well, the next thing we'll consider here is multiplication by a scalar. So let's say we want to say, hey, this airline company A is opening up some new borders, some new airplanes into their force, and they're saying, hey, we're going to offer triple the amount of flights we usually have. So we're going to find the matrix, switch colour white, we're going to find the matrix 3A that will represent the total amount of flights offered with the new airplanes installed. So this is the exact same thing as 3 times 0, 3, 5, 3, 0, 4, 5, 4, 0. And to find that, to find the product of a scalar and the matrix, all we have to do is multiply each individual element by the scalar. So what's 3 times 0? 0. 3 times 3 is 3 squared, which is 9. 15, and then we just respectively go along with all of these. I apologise for that. 15, 12, and 0. So that's the amount of flights offered with the new planes installed. And that's about it, really. These are the most basic operations that can be done with matrices. So just to recap, we can find the sum of two matrices as long as they are conformable, which means they have the same dimensions. So you can't add a 3 by 3 and a 2 by 2 matrix, or a 1 by 5 with a 2 by 7, or yeah. And to multiply a matrix by a scalar, all we have to do is multiply each individual element of the matrix by the scalar. So these two properties are really basic, and it's worth some practice. So I recommend, for those of you who have the MEI textbook, to go look for the first exercises on matrix operations, and you need to practice a few questions. I'd say like the first 1 or 2 questions, just so you have a proper firm grasp on what's actually going on here. So thank you very much for watching. I really hope this helped introduce what a matrix actually is and what we do with them, and I will really hope to see you next time where we talk about the multiplication of matrices. So thank you very much.